Now let's continue with example 7. We're going to change gears to something new now. We're going to consider some angle measurements in triangles. Consider the same problem above. How fast is the angle of elevation of the camera changing at that moment when the shuttle is 4,000 feet high? Okay, angle of elevation. Okay, the angle of elevation, we need to label that in our picture. So here's we're going to call that angle theta. We just traditionally call the angle theta. We know that 3,000 here is a constant. Y and Z are still changing, but our camera is moving so as to keep the space shuttle in focus if we go back to the original problem. All right, we still have the shuttle rising vertically at 800 feet per second, so that was dy dt was 800. And we're still talking about when it's 4,000 feet high. Okay, so how fast is the angle of elevation of the camera? So we're looking for d theta dt. So what is that at that moment when the shuttle is 4,000 feet high? So when y equals 4,000. Okay, so we see here that this is no longer a Pythagorean theorem relationship. We've got an angle involved. That's when we switch over to trig. We need a trig ratio that involves these measurements and this angle in the triangle. Okay, we know something about y. We know that x is 3,000, so we'll use these two sides with this angle, and since y is the opposite side, and 3,000x, there's the adjacent side, opposite over adjacent, that's tangent of theta. So that is the equation that we want to use. The tangent of theta is y over 3,000. Okay, it's y over x, but since x is constant, we go ahead and put that in. And always plug those constants in before you differentiate. All right, now let's differentiate this function. So if you think back, the derivative of tangent theta is secant squared theta d theta dt. That's the part we always kind of forget right there. I know I do. Equals, okay, this y over 3,000 is also 1/3000th y, so it makes it easier to see to do the derivative. So the derivative is 1/3000th dy dt. Okay, so now we need to see what do we know, what do we don't know. We are looking for d theta dt. We know dy dt is 800, so we need to figure out what about this secant squared theta. Now we don't have to actually find theta, that's not the issue. We just need its secant, and then we're going to square it. Well, what do we know about secant? Secant is the reciprocal of the cosine. So I come over here to my figure, there's my angle. The cosine is adjacent over hypotenuse. All right, remember a while ago, we're talking about when y is 4,000, then z was 5,000. So the cosine here is 3,000 over 5,000, and I'm going to do that to the side. So the cosine of theta is 3,000 over 5,000, which simplifies to 3/5. Therefore, the secant of theta must be 5/3, and the secant squared theta is 25/9, and that's the number, that's what we need for this problem. So we're going to substitute this in here. So I've got 25/9 times d theta dt equals 1/3000th times 800. Okay, so we're solving for d theta dt. We're going to divide by 25/9, which is the same as multiplying by 9/25, and then we just go ahead and do the math from there. Okay, and all of this comes out to be 12 over 125, and it's radians per second, and that's d theta dt.